Alright, let's look at the first problem from this more practice folder. Let's get started with the first question. In this first question there are 5 stations, so let's make it a process flow diagram with 5 stations, 3, 4 and 5. The first one has a processing time of 50 seconds, the second one has a processing time of 60, 30, 45 and 40. So this is in seconds per customer. Okay, now we can, given that there's only one worker in each of them, we can calculate the capacity. Let me use a different color here. The capacity is 1 over 50, 1 over 60, 1 over 30, 1 over 45, 1 over 40 customer per second. You can see that the second station, right, is the bottleneck. So this answers your first question. So the first question is the worker 2 is your bottleneck. What is the capacity? Well, the capacity is in terms of customer per second. We know that is 1 over 60 customer per second, but that's not what the answer wants. The answer wants in terms of customer per hour. You can find the conversion factor is 3600. 1 over 60 times 3600 is 60 customers per hour. Be careful about this phrase. People sometimes like to say, ignoring the production of the first and last units in almost every question related to process analysis. I don't use it as much. It's just to understand that it is a process analysis. We are only studying when things are stable. Okay, the next question says, what is the utilization of worker 4? Well, the formula for utilization is flow rate divided by capacity, right? So flow rate divided by capacity, we know the flow rate is 1 over 60, and the capacity of the fourth worker is 1 over 45. Comes out to be 45 divided by 60, which is about 75%. The fourth question says, what's the average labor utilization? To calculate the average labor utilization, we need cycle time. The cycle time is 60 seconds, right? After you find the cycle times, the idle time here is 10, idle time here is 0, 30, 15 and 20. If you add them all up, it comes out to be, if I did the math right, it comes out to be 75 seconds. So the formula for the average labor utilization is total labor content, that is 50 plus 60 plus 30 plus 45 plus 40. It comes out to be, if I did everything correct, 225 divided by 225 plus 75, that is 300, comes out to be 75%. Please make sure my maths are correct. Alright, assume the workers are paid $50 an hour. What is the direct labor content? Remember, to calculate the direct labor content, we need total wage on the top, that is $15 times 5 total wage. The flow rate, well, we have been only looking at the flow rate in terms of 1 over 60, but to convert that into hour, we already did that, 60 customers per hour. That was the processing capacity, but demand is not the constraint, so we know that is the flow rate 2. Comes out to be $1.25 per customer, well, in this case per bike. Alright, let's look at the next question. In this question, between this 9 hours and 9 a.m. and 10 a.m., what's happening is 255 customers checked in. So you can see, in terms of rate, given that in 1 hour 255 customers checked in, you can think of this as rate, 255 customers per hour. So if there is 2 hours, you have to divide it by 2. So you see the inventory is 35. I want to find out how long does it take to process, to go through the line. Okay, so we can use I equals to RT. I is what we are interested in. We already know I is 35. T is what we're interested in. R is 255. We're going to find T. T comes out to be 35 divided by 255. In terms of, so given that this rate is in terms of hour, you can get whatever the value and multiply it by 60 to convert into minute. I got 8.23 minutes. Alright, so this was an hour. I had to convert that. So remember, this was an hour. I had to multiply it by 60 to get it to 8.23. Alright, the next question is, in this company, the COGS was 3.2 million. The COGS was 3.2 million, and he keeps the inventory of for 5.5 days. It's pretty similar to that Gelaro example we used. We want to find out what is the annual inventory turns. Given that we already know the T, the best way to find annual inventory turn is just 1 over T, but you want to convert that T in terms of year first. So we can do 5.5 divided by 365, right? We have that in terms of in terms of year. Then annual inventory turn is 1 divided by 5.5 divided by 365. You can convert into decimal if you want. I'm going to leave it that way. 365 divided by 5.5 comes out to be 66.36. The next question is, given that he holds 5.5 days of supply of inventory, how much is that in terms of dollar? Well, that is the interesting problem in this case. So he holds 5.5 day worth of supply. Well, you can use I equals to RT, right? We know R is comes from COGS, which is 3.2 millions. T is well, you need, this is 5.5 days, but you need in terms of years. So 5.5 divided by 365 is 0.01506. I is about $48,219. That's what I get. So at any given time, he holds $48,219 worth of inventory.